Okay, so let's move on to matrix multiplication. Now normally multiplication, very easy. Multiplication could care less if anything was the same, right? We can multiply x's and y's. We can multiply an x squared and an x, right? Multiplication usually doesn't care if things are the same. We could do 1/2 times 2/3, no problem, right? Well, when it comes to matrix multiplication, it's a little picky. So let's look over here. Here are two orders. So 2 by 3 is one of the matrices, and I'd like to multiply it by another matrix that has an order of a 3 by 1. So in order for me to check to see if these two matrices can be multiplied together, I look at their orders. And here's what I'm looking for. I am looking to see, remember, this is a column, right? This is a row, this is a column, this is a row, this is a column. What I'm looking to see is this. I am looking to see if the number of columns in the first matrix is the exact same as the number of rows in the second matrix. That's what I'm looking for. Because if they are, then I can multiply them together. If they are, that means I can multiply them together. If the number of columns in matrix 1 is exactly the same number as the number of rows, that means I can multiply them together. With me? Okay. And then, so these are equal, so check. And then my resulting matrix would be the number of rows on the first and the number of columns from the second. My resulting matrix will be a 2 by 1. When we do an example, you'll see it come to life a little better, okay? But this is what I'm looking for. Now, one thing you need to be very aware of. Matrix multiplication is not commutative. Like, what do you mean? You know, if you do 5 times 8, it's the same as 8 times 5, right? Well, that's not always true with matrix multiplication. For instance, if I want to multiply these two matrices in the reverse order, if I want to do the 3 by 1 matrix, right, which was the second one, and I want to multiply it by the 2 by 3, which was the first one, doesn't always work. Because notice, rows, columns, the number of columns on matrix 1 and the number of rows on matrix 2 are not equal, which means you can't do matrix multiplication here. Not happening. Can't do it. Nope, 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 nope. With me? No matrix multiplication here. No matrix multiplication can be done here. Good? All right. Now, remember, in the last video on adding and subtracting matrices, we had these 7 matrices. So please go back and take a look at that video to get those matrices again if you need them. And these were the orders we wrote down for each matrix, right? Okay. Now here's what I want you to see. I want to see which of these matrices I would be able to multiply together. So let's just take a look. Matrix A is a 2 by 2, right? So think about this. If I want to take matrix A first, it ends in a 2, which means whichever matrix I want to take second has to begin with a, that's right, a 2. Well, that would be matrix D, wouldn't it? So I could multiply matrices A and D, couldn't I? But I could also take matrix A and multiply it by, yeah, F, because F starts with a 2. Right? Okay. Let's look at matrix B. Matrix B, that's the one I want to write down first. It ends in a 3, which means the second matrix has to start with a 3. Well, that would be matrix C, wouldn't it? What else? Oh yeah, E. So I could do B times E, couldn't I? But I could also do B times G, because it also starts with a 3, doesn't it? Good. Let's look at matrix C. Now, I want that one first, and it ends with a 1, which means whatever matrix I multiply with it, the second matrix has to start with a 1. Good. Oh, I see matrix B. It starts with a 1. So yay for that. Cool? Now this one, it looks like B times C and C times B. It looks like that one I can multiply in the reverse order. But I promise you, the result is not the same. Okay? It is not the same. And you're like, why not? Take a look. B times C. B is a 1 by 3. C is a 3 by 1. Since these are equal, we can multiply them, right? The resulting matrix is going to be a 1 by 1. What about matrix C times matrix B? We can multiply them in the reverse order. C is a 3 by 1. B is a 1 by 3. These guys are equal, so we can multiply. But the resulting matrix is a 3 by 3. Oh yeah, way different. Much, much larger. Here I get 1 row and 1 column, which means 1 number. Here I have 3 rows, 3 columns. Yeah, that's like 9 numbers, right? Very different. With me? Okay, let's keep going over here. Well, it looks like that was the only one. So D. D ends in a 2. Good, we can multiply it by A. And looks like you can multiply it by F, right? How about E? E ends in a 2. Good, looks like you can multiply it by A. What else? And D. Good. What else? And F. And that's it. What about matrix F? It ends in a 3. So what could you multiply it by? Good, you can multiply it by C. And matrix F ends in a 3. What else? Good, you can multiply it by E. And it looks like you could also multiply it by G, couldn't you? Okay, matrix G. It ends in a 2. What can we multiply matrix G by? A, since it starts with a 2. What else? D, it starts with a 2. What else? Yeah, F, because it starts with a 2. And that's about it, isn't it? So we have, based on these 7 matrices and their orders, these are all the multiplication problems that we can do with those 7 matrices. Cool? Okay, so hang in there. We're actually going to learn how to multiply matrices. Okay, so let's look at this first problem. We spoke about, just a few minutes ago, what matrices we could multiply together. And we said we could multiply matrix C, B times E in that order. And so I've written down the size of each matrix, right, just so we can do a double check. And what we are noticing is that the number of columns here is the same as the number of rows. Those are equal, which means my resulting matrix will be a 1 by 2. Agreed? Okay. Now here's why we need to make sure that these number of these number of columns and these number of rows are exactly the same. Here, this, by the way, here's matrix B, matrix E, okay? This matrix is 1 row, 3 columns. That means I've got 3 numbers here if I look at it in just this format. This matrix is 3 rows, 2 columns. But I have 3 numbers in each of those columns. You're like, wait, that's talking backwards. I know, that is talking the opposite of what these numbers represent. But here's the reason why. Making certain these numbers are the same makes certain that the amount of numbers in these rows is exactly the same as the amount of numbers in these columns, because matrix multiplication is a bunch of distribution problems. Okay? Matrix multiplication is a bunch of distribution problems. I'm going to take each row from the first matrix and I'm going to distribute it to each column in the second matrix. Remember, the result was a 1 by 2. This represented the rows, this represented the columns. I'm going to take each row from the first matrix and distribute it, multiply it to each column in the second matrix. That's matrix multiplication. Each row in the first matrix is getting distributed to each column in the second matrix. Now, I put up a very simple problem here because the first matrix only has one row, and that's fine. So, just watch for a second and until you get the hang of it. So, since these two numbers are the same, they're equal, I'm going to end up with a 1 by 2 matrix. I'm going to take each row from the first matrix and distribute it to each column in the second. Now, pay attention. First row is going to get multiplied by first column, which means the result goes in the first row, first column position. Because I'm multiplying first row by first column. With me? Okay, so first row, first number is a -2. First number gets multiplied to first number. I'm multiplying by first column. First number gets multiplied to first column. First number. So I'm going to do -2 times 2. The second number, which is 6, gets multiplied to the second number, which is 4. The third number, which is a 1, gets multiplied to the third number, which is a 3. So let me back up. I'm taking the first row by the first column. First number gets multiplied to first number, second number to second number, third number to third number. Good? Okay, now, I'm only supposed to get one number in this first row, first column position. So I'm going to add all these multiplication problems together to get one number in the first row, first column position. Got it? Okay. Now, I'm done with taking the first row to the first column. Now I'm going to take the first row to the second column, which means my answer goes in the first row, second column position. And I'm going to do the same thing. First number to first number. Second number to second number. Third number to third number. And then you need to add them together. Looks like I made this one just a little too long. Again, this first row gets distributed to this second column. So the answer goes in the first row, second column position. So first number to first number, -2 times 0. Second number to second number, 6 times -1. Third number to third number, 1 times 5. Cool? Okay. Now, I'm done with this first row, and there's no other rows in this first matrix, so I am done with matrix multiplication. Now I need to simplify this. So, -2 times 2, good. 4, and I'm adding it to 24. Whoops, that's a -4. And I'm adding it to 3. In the first row, second position, second column, yeah, negative 2 times 0, well, that's just 0. Plus a negative 6 plus 5. And adding everything together, doing my simplifying, gives me 23 and negative 1. The result is 1 row, 2 columns, which is exactly what we said we were supposed to get. 1 row, 2 columns. Yes? Okay, hang in there. I've got another one for us that's going to be a little bit bigger on the first matrix so we can see it develop a little bit more. But my suggestion is rewind this particular problem and make certain you understand how we took this first row to each of these columns. Okay, so let's look at the second problem. I want to multiply matrices A and F together. Remember, just a few minutes ago we said we could. Matrix A is a 2 by 2, matrix F is a 2 by 3. And if I take a look, these two inner numbers are equal, and these two outer numbers, the result will be a 2 by 3. That's the number of rows, that's the number of columns, right? Which means out of the first matrix, I'm going to take their rows out of the first matrix and I'm going to distribute it to every column in the next matrix. Okay, so if you just want to watch and then rewind and write it down and work along with me, that's fine. But let's make certain that you understand what's happening here. So I am going to give myself a little bit of room and I'm going to kind of start the problem down here. I'm going to take this first row and I'm going to distribute it to this first column. They both have 2 numbers in them, which is why I can do it. Okay? So, since I'm multiplying the first row by the first column, the answer is going to go in the first row, first column position. Cool? So remember, first number to first number, so 4 times negative 6, second number to second number, negative 3 times 4, and then I add them together so I can get a single answer there. Got it? Okay. And then I am going to take my first row and now I am going to distribute it to the second column, which means my answer is going to go in the first row, second column position. First number to first number, second number to second number. And then I need to add them together to get a single number in that spot. Again, first row went to second column, so first number to first number, second number to second number. Got it? Okay, but I still have another column, which means I am not done with my distributing. I still need to take this first row and now distribute it to the third column, which means the answer is going to go in the first row, third column's position. So, first number to first number, second number to second number. And then I add it together. With me? Okay. So did I multiply this first row by each of these 3 columns? Yes, I did. So technically I am done with the first row in that first matrix. And now I get to work on the second row and do the same thing. I get to distribute the second row to each of these 3 columns. And now all my answers are going to go in the second row position. Following? Okay, so let's see. Second row to first column. Answer goes in second row, first column position. Same thing. First number to first number. Second number to second number. And then we get to add them together. right? I am done multiplying the second row to the first column. And now I have to multiply the second row to the second column. So my answer goes in the second row, second column spot. First number to first number. Second number to second number. And then I add them together. With me? Getting the hang of it? Okay. But that second row still has a third column it has to get multiplied to. Again, first number to first number, second number to second number, and then you add them together. With me? Okay, I'm going to pause here a second. Something I'd like you to notice. First row had the numbers 4 and -3, correct? Well, do you notice in the first row, 4, -3, 4, -3, 4, -3? And that first row got multiplied to the first column, second column, and third column, right? Okay. But then we had to take the second row, which had the numbers 2 and 1. So do you notice the numbers 2 and 1 are in the second row? And it got distributed to each of these three columns, correct? In the first column were the numbers -6 and 4. Do you notice in the first column all I see is the -6 and the 4? Second column had the 1 and the 3, and there's the 1 and the 3 in the second column. Third column had 2 and -1. Well, there's 2 and -1 in the third column. 4 and 3 were the first row, first column, right? 2 and 4 were in the second row, first column. 4 and -3, first row, but 1 and 3 were the second column, second column. You with me? You seeing it a little bit? Okay. And now we have to simplify this. So, let's see if we can do it all in one shot. Shall we? So we have a -12. We'll just write it down. -24 plus a -12. Agreed? 4 plus a -9. 8 plus 3. Second row, we have what? A -12 plus 4, a 2 plus 3, and then a 4 plus -1. And when we add these up, what do you get? -36, first row now, -5 and 11. How about in your second row? -8, 5, and 3. Well, look, I end up with a 2 by 3, which is exactly what we said we should have ended up with, a 2 by 3. Does this make sense? Okay, again, if you need to, rewind this particular problem and see if you follow along. I got one more for us, so stay. Okay, let's look at this third problem. Remember, earlier we said we can multiply matrices F and G together, and when we do that, these middle two are the same, they're equal, which means we can multiply them and the result's going to be a 2 by 2, right? Okay, so let's see if we follow along. I'm going to take each row of the first matrix, because that's the rows here, and I'm going to distribute it to each column in the second matrix, because my result is the column here, right? Okay. So I'm going to start my work down here because I'll have more room. So first row is going to get distributed to first column. So let's see if we follow along. First number to first number, second to second, third to third, right? And since I'm taking the first row and the first column, my answer goes in the first row, first column spot. So first number to first number, second number to second number, third number to third number. And then I get to add them together, don't I? But I'm not done with this first row because there's a second column here. So now I'm going to take the first row to the second column. Again, first number to first number, second number to second number, third number to third number. And my answer is going to go in the first row, second column spot, because I'm multiplying the first row by the second column. Good? Okay, so first number to first number, second number to second number, third number to third number, and then we get to add them together. Cool? Okay, so I'm done with the first row because there's no other column for me to distribute it to. Now, I need to work on the second row to each of these columns. So we're going to do second row to first column right now. My answer goes in the second row, first column spot. Remember, first number to first number, second number to second number, third number to third number. So, first number to first number, second number to second number, third number to third number. And then I add them together so I get a single number in that spot. Good? Okay, are we done with that second row? Nope, we're not, because that second row has to get multiplied to the second column. So you get the hang of it? All right, so see if you follow along. 4 times the negative 2, 3 times the 3, and negative 1 times 2, and then I get to add them together. Good? And I'm done with the second row because there's no other column to distribute. And there's no other row for me to distribute because all these rows are done. So we're done with our distribution. And now we have to simplify this. And it looks like I'm going to get the 2 by 2 that we said we were supposed to get. So let's check it out. So what do we have here? Negative 42 plus 1 plus 8. Now it looks like we have a 12 plus 3 plus 4, right? And then it looks like we have a 28 plus 3 minus 4. And over here we have a negative 8 plus 9 minus 2. Okay, so what do we get when we add all that together? Yeah, that's a negative 33. That's a 19. What do we get? That looks like a 27. And this one looks like a negative 1, right? Okay. So I ended up with a 2 by 2 like we said we were supposed to. And this 2 by 2 was arrived by taking the columns in the first matrix and multiplying it to the columns, taking the rows in the first matrix and multiplying it to the columns in the second matrix. Does that make sense? Okay, so here's the deal. If you need to, you go back and you rewind this entire lecture video to make certain you understand how to multiply matrices. Once you get the hang of it, it becomes very simple to do. But you just got to keep track of which row to which column. Remember, first number to first, second to second, etc. Cool? Okay, have fun with matrix multiplication, and I'll catch you on the flip side.